Good morning, students. So last class we discussed about the introduction to cables, construction of cable, and also types of insulating materials. That means a cable is nothing but one or more conductors surrounded with a suitable insulation and completely covered with a protecting cover. Now today class we go for the classification of cables and also insulating resistance. Classification of cables is nothing but cables are classified depending upon the voltage rating. The voltage is up to 1000 volts. Cables are used low tension cables, that is LT cables. Another classification is high tension cable, that is these cables are used up to voltage rating of 11,000 volts. So another classification, that is super tension cables. A voltage rating from 22 kV to 33 kV, the cables are used as ST cables. From 33 kV to 60 kV, the cables are used as EHT cables, that is extra high tension cables. So beyond 132 kV, that is 220 kV or 400 kVs or 750 kVs also, we are replacing extra super voltage cables. Generally, cables are classified according to type of insulating material and also according to voltage rating. The second one is the basic one and generally preferred one also. That means the cables are classified according to voltage is chosen as a best one compared to type of insulating materials. According to voltage rating, as usual, the cables are classified as LT cables, HT cables, ST cables, and EHT cables, and also extra super voltage cables. Now we go for the each one with a construction figure. First one is single core cable, single core low tension cable, LT cable. So look at the figure. So the single core low tension cable consists of single core, single conductor that may be made up of standard copper conductor or it may be aluminum. So that conductor is covered with a insulating material, that is insulating material is made up of impregnated paper. Here that means in low tension cable we are utilizing impregnated paper as insulating material. So insulating material is surrounded by a lead sheath and then that is surrounded by a serving. Serving is nothing but complete protection. So now this single core low tension cable may be utilized as single core or it may be a 2 core or it may be a 3 core and sometimes it may be utilized as 4 core also. That means 2 single cores, 3 single cores and 4 single cores. So this single core low tension cable has a ordinary construction, that is simple construction, because the stresses developed in the cable for a low voltage, generally 6600 volts, are very small. That means electric stresses developed in the core is very small in the low tension cable. So this low tension cable consists of a circular core of tinned copper and insulated by a layers of impregnated paper, and that insulation is surrounded with a lead sheath. Why? Because we are utilized to reduce the moisture from the atmosphere and enter into the inner parts of the cable, that is conductor and insulating materials. So lead sheath is used to prevent the moisture into inner parts. In order to protect the lead sheath from the corrosion, an overall serving of compounded fiber material like jute is provided. Now go for the three-phase service cables for three-phase service. To deliver three-phase power, either three-core cable or three single-core cables may be utilized. For single-core cable, for single-phase supply, we are utilizing single-core only. But to deliver three-phase power, we are utilizing three-core cables, otherwise three single-core cables. The voltages up to 66 kV, three-core cable or multi-core construction is preferred due to economic reason. So last class we discussed about the construction of cable. In that figure, constructional figure will show the three cores. Suppose voltages beyond 60 kV, that is 132 kV, 220 kV, 440 kV or 750 kV. These three core cables becomes too large and too bulky. That's why, therefore, single core cables are used. The three core cables, that means to deliver three-phase power, the cables are generally used in three-phase services is first one belted cable up to 11 kV, belted cables used up to 11 kV, screened cables, these are used voltage rating from 22 kV to 66 kV, pressure cables, these are used beyond 66 kV. First one belted cable, look at the figure, three cores or three conductors are separated to each other and insulated to each other also. So this line will give the thickness of insulation between the conductors. So surrounded by a paper belt, that is surrounded by a paper insulation, impregnated paper insulation, and surrounded by a lead sheath. We cannot shown in the armoring, bedding, all these things. The figure shows the constructional details of belted cable, three-core belted cable. The cores are insulated from each other by layers of impregnated paper. Another layer, look at the figure, another layer of impregnated paper called paper belt is wound around the insulated cores, grouped insulated cores. The gap between the insulated cores is filled with a fiber insulating material like jute. That means it gives a circular cross section of the cable. The cores are generally standard and may make better use of available space. The belt is covered. This is the belt. The belt is covered with a lead sheath to protect the cable against moisture coming from the atmosphere and also mechanical injuries whenever we are led into the cable will lead into the earth. Now a lead sheath is covered with one or more layers of armoring with an outer serving. So those two are not shown in the figure. Armoring and serving is not shown in figure. Now this belted type construction is suitable only low and medium voltages. Why? Because the electrostatic stresses developed in the cable for these voltages are more or less radial. that is across the insulation. Generally for low tension, the electrostatic stresses in the belted cable are very less, generally up to 6600 volts. Now coming to the belted cables, it may be these belted cables are suitable for low and medium voltages, such that the electrostatic stresses developed in the cables of these voltages are more or less, that is across the insulation. The tangential stresses become important for high voltages. These stresses act along the layers of paper insulation and it will set up a leakage current along the layers of paper insulation. This leakage current causes local heating, resulting in the risk of breakdown of insulation. In order to overcome this difficulty or this leakage current, now we are utilizing a screened cables, that is the improvement of belted cables, where the leakage current are conducted to earth through metallic screens. That means in screened cables, the leakage currents are flowing through the earth through the metallic screens. Here, belted cable, there is no metallic screens. Now that metallic screen extra is provided in the screened cables. So now how the leakage current will flowing through the earth through the metallic screen, we can discuss the next classification, that is screened cables. So screened cables are meant for use up to 33 kV, right, in some special cases. So this screened cables may be used voltage rating up to 66 kV also. Generally, two types of screened cables are there: H-type cables, SL-type cables. Coming to the H-type cables, the constructional details of H-type 3-core H-type cable as shown in figure. Here, look at the figure. So the difference between belted and screened. Each core is insulated by layers of impregnated paper. The insulation of each core is covered with a metallic screen. So here, this point is not there in belted cable. So here also, when belted cable also, 3 cores are insulated to each other with a impregnated paper. That's enough. And then a belt is covered with a metallic screen. A belt is covered with a insulation. But here, 3 cores are insulated with a impregnated paper, and then the insulation on each core is covered with a extra metallic screen or metallic screen, which is usually consists of a perforated aluminum foil. That means the cores are laid in such a way that metallic screens make contact with one another. Metallic screen of core 1, metallic screen of core 2. Look at the figure clearly. Metallic screen of core 1, metallic screen of core 2, metallic screen of core 3. Both are touches to contact with each other, such that the developed leakage current, where high voltages, whenever you are applying high voltages, so it may electrostatic stresses are developed such that they may develop leakage current. That leakage current is directly put into the earth through the metallic screens. Now an additional conducting belt, that is copper woven fabric tape, is wrapped around the 3 cores as usual in belted cable. The cable has no insulating belt, but lead sheath is there, bedding is there, armoring and serving follow as usual. It is easy to see that each core screen is in electrical contact with conducting belt and a lead sheath. That means core screen, that is metallic screen, is in electrical contact with conducting belt and also lead sheath. As all the 4 screens, that is 3 core screens and 1 conducting belt and a lead sheath are at earth potential. Metallic screens, 3 conductors having 3 metallic screens and 1 conducting belt and also lead sheath, they are in at earth potentials. That means all are contact with earth potential. The electrical stresses are purely radial and consequently dielectric losses are reduced. Why? Because it will going to the earth. So that is the major difference between the belted cable and screened cables. What are the advantages of screened cables? Perforations in the metallic screens assist in the complete impregnation of the cable with the compound and thus a possibility of air pockets or voids, that means vacuous spaces in the dielectric is eliminated because of metallic screens. So leakage current is reduced and also dielectric is, air pockets or voids are reduced. So metallic screens may increase the heat dissipating power of the cable. Another type of SL type cable is, it is basically a H type cable, but the screen round each core insulation is covered by its own lead sheath. So belted cable, there is no metallic screens. Screened H type, a metallic screen is surrounded by the each and every conductor, and then 3 metallic screens are contact to each other, right? Now around the metallic screen there is no lead sheath, but here each conductor, each core is insulation is covered by its own lead sheath, but only armoring and servings are provided. Here extra lead sheath and is not provided. Every conductor have its own lead sheath such that armoring and serving is provided, right? So operation and all are same as H type, but here each core having its own lead sheath. What is the advantage because of that property? What is the advantage? A separate sheath minimizes the possibility of core to core breakdown. All cores are contact to each other because of metallic screen. So there is no any possibility of core to core breakdown. That core to core breakdown will be vanished or reduced because of every lead sheath of every core. Bending of cable becomes easy due to the elimination of overall lead sheath. Overall lead sheath is eliminated. You have to put particular lead sheath on each and every core. That's why bending of cables is easy. What are the disadvantages? Because of one lead sheath is used in the screened cables or belted cable. But here, in place of one lead sheath, we are utilizing 3 lead sheath, as much thinner than the single sheath of H cable, and therefore we are take care of much care about the manufacture. At the manufacturing time, you have to take care about the so much care will be taken to manufacture the screened SL type cables. Now go for the what are the limitations of solid type cables. So above cables are referred to solid type cables because solid insulation is used and no gas or oil circulates in the cable sheath. There is no oil, there is no leakage of oil, or there is no gas is not circulated. The voltage limit for solid type cables are 6 kV due to the following reasons. As solid cables carries the load, the conductor temperature increases and the cable compound expands. This action stretches the lead sheath, which may be damaged. So whenever the load will be carried, that means temperature increases. Current carries, that means temperature increases in each and every part of the cable. That may be increase the area of cross section. That means cable may be expanded. So that may be stretches the lead sheath, which may be damaged sometimes. When the load on the cable decreases, Conductor cools and partial vacuum is formed within the cable sheet. Then the pinholes are present in the lead sheet. Moist air may be drawn into the cable. If load increases, the conductor temperature increases such that cable may increase their cross-sectional area. That means it may be expands. So that may be problem in the lead sheet. Stretches in the lead sheet, right? Suppose load decreases, conductor cools, temperature decreases, temperature of the conductor decreases, such that a small vacuum is formed within the cable sheet that may present in the some small moist air may be entered into the lead sheet. In practice, voids are always present in the insulation of a cable under operating conditions. These voids are formed as a result of differential expansion and contraction of the sheath and impregnated compound. The breakdown strength of void is considerably less than that of insulation. If the void is small enough, the electrostatic stresses across it may cause its breakdown. The voids nearest to the conductor are the first to the breakdown, then the chemical and thermal effect of insulation causing permanent damage to the paper insulation. These are the limitations of solid type. That means load increases, temperature increases, such that the cable diameter increases, that may be stretched into the lead sheath. So sometimes it may be damaged. Suppose load decreases, temperature decreases, that may form to some pinholes at the lead sheath. So therefore moisture may enter into the lead sheath, right? Pressure cables. When the operating voltages are greater than 60 kV, it may be 132 kV or 220 kV, the pressure cables are used. In such cables, the voids are completely eliminated by increasing the pressure of compound. For this reason, they are called pressure cables. To reduce the voids in the insulation, we must increase the pressure such that voids are vanished. So that's why these cables are used, pressure cables, and it may be used greater than 6 kV, that is 132 kV or 220 kV. Two types of pressure cables are there: oil filled cables and gas pressure cables are commonly used. Oil filled cables. In such cables, the channels or ducts are provided in the cable for oil circulation. The oil under pressure is kept constant supplied by the external reservoirs placed at a suitable distance. Oil under pressure compresses the layers of paper insulation and is forced into any voids that may have formed between the layers. Oil filled cables are three types: single core conductor channel, single core sheath channel, three core filler space channel. Look at the figure. Figure shows the constructional details of single core sheath channel or oil filled cables. These are the small ducts or channels filled with oil because of circulation of oil. This is the paper insulation conductor and it is a grooved sheath. In this type of cable, conductor is solid, similar to that of solid cable, and a paper insulation, impregnated paper insulation. However, oil ducts are provided in the metallic sheath. Oil channels are provided in the metallic sheath as shown in figure. Suppose go for the three core cable, three core oil filler cable. So this is single core oil filled cable. Now go for the three core oil filled cable. The oil ducts are located in the filler spaces. That means in between two conductors. So this is oil duct, this is oil duct, this is oil duct. So these channels are composed of perforated metal, ribbon tubing, and are at earth potential. The oil-filled cables have three principal advantages. Formation of voids and ionization are avoided. The temperature range and dielectric strength are increased. If there is any leakage, the defect in the lead sheath is at once indicated and the possibility of earth fault is decreased. Main disadvantage of oil-filled pressure cable is high initial cost, and it is a complicated system whenever you have to lead into the head. Last one, gas pressure cable. Figure shows the external pressure cable designed by a Ostrander, Vogel and Bowden. The construction of the cable is a triangular shape. Look at the figure, triangular shape, and the thickness of lead sheath is 70% of that of solid cable. The thickness of lead sheath is 75% of the solid cable. Now the triangular section, why we are utilizing triangular section? This triangular section may reduce the weight and gives low thermal resistance, but the main reason for triangular shape is that the lead sheath acts as a pressure membrane. Because of triangular shape, we may reduce the weight, and also we may the lead sheath may act as a pressure membrane, and this sheath is protected with a thin metallic tape. The cable is led in the gas-tight steel pipe. The pipe is filled with a dry nitrogen gas at a 12 to 15 atmospheric pressure. The gas pressure produces radial compression and closes the voids. That means reduces the voids or vanish the voids that may have formed between the layers of paper insulation. The main advantage of gas pressure cable is it may carry more load current, such that this type of cable may be used for higher voltages than the normal cable. Even though we are utilizing high voltages, the maintenance cost is very small, and the nitrogen gas helps quenching the flame. So those are the classification of cables. Next, go for the important derivation in our B.Tech. So the derivation is very important, and also problems also very important for this one. Gives 5 marks, problem also 5 marks. Suppose they given derivation, so problem is not given. Suppose they don't given derivation, they given problem, right? Insulation resistance of a single core cable. Generally, the cable conductor is provided with a suitable thickness of insulating material, right, in order to prevent the leakage current in the conductor. Generally, cable, first of all, conductor is there, surrounded by the conductor, insulation paper is there, right? So conductor is provided with a suitable thickness of insulating material in order to reduce the leakage current. The path for leakage current is radial through the insulation. Now the opposition offered by the insulation to leakage current is known as insulation resistance of a cable. The opposition offered by insulation to leakage current, opposition offered by the leakage current is known as insulating resistance of a cable. Generally, the cable may be operating with a satisfactory conditions such that the insulating resistance is very high. Let us consider a single core cable of conductor radius R1, conductor radius small r1 and sheath radius small r2 as shown in figure. Conductor radius is small r1, sheath radius small r2 as shown in figure. Let small l be the length of the cable and rho be the resistivity of the insulation. Now consider a very small layer of insulation of thickness dx. Now I am taking a small dx, small thickness of insulation dx. at a radius of small x, with a radius of small x. Now the length through which leakage current tend to the flow is dx, and the area of cross section offered by this flow is 2 pi xl, right? 2 pi r, 2 pi r is 2 pi xl. Therefore, insulation resistance of conductor layer is rho dx by 2 pi xl. Now this is a small length dx, small insulation dx. Now this is applicable to total cable, whole cable. Therefore, R is equal to integral of limits small r1 to r2, rho dx by 2 pi xl. Here rho is the constant, 2 pi is the constant, L is also constant, but x is not a constant. Therefore, rho by 2 pi L taken as a common, and integral r1 to r2 1 by x dx. So by applying the integration, 1 by x is nothing but log x, and then applying r1 r2 log r2 upper integral minus log r1 lower integral, right? So therefore, capital R is equal to rho by 2 pi L log A minus log B, that is equal to log A by B, log R2 by R1 base E, ohms. This is the insulating resistance of a cable, very important. So R is inversely proportional to L. Remember, R proportional to 1 by L. This is most important for competition examinations. So the insulation resistance of a cable is inversely proportional to the length. Insulation resistance of a cable is inversely proportional to its length. In other words, if cable length increases, its insulating resistance is decreases. Suppose cable length decreases, insulating resistance is increases. So very important. So this particular line may be utilized in, used, remember, and they may use it in competition examinations, right? Thank you one and all. So today class we discuss about the classification of cables: low tension, high tension, super tension, super extra tension, extra super voltage cables are maybe classified. So low tension, then high tension cables are classified as 3 types: belted, screened cables. Again, screened cables are classified as H type and SL type. Then we go for the beyond 66 kV. We used pressure cables. Pressure cables are maybe classified as oil filled cables as well as pressurized gas filled cables, right? After them, derive the most important one, derive the insulation resistance of a single core cable, right? So next class we discuss about the derivation of capacitance of a single core cable, right? Thank you one and all.